Okay, so let's try one more thing. When we study genetics, we also use the information that we just filled out in the pedigree above to try and make predictions about what could happen in the future. At the end of the video, where Rosemary was talking about how hard her three of the six kids really had it, that they had a lot of bullying in school, that they had some complementary sight issues, their vision was really low. They were having trouble in school for a collection of different reasons. And they were talking about how very isolated these kids are because the rest of the community doesn't understand it. They think that they are diseased. They think that they're contagious. So these poor kids are really isolated, which is a beautiful thing that they have a really big family, so the whole collection can stay together. But there's a really, really big concern for Rosemary and her current spouse of taking care of these kids, getting them healthy and strong, and then having a high quality of life. One of the pieces that was brought up was the pigmentation of the albino children leaves them very, very susceptible for getting sunburnt and being exposed to the sunlight and not resisting it, as well as their browner brothers and sisters. That melanin in the skin is very, very protective against the dangerous sunlight. So, Joao Paulo, Rebecca, and Marie Alice have a much, much better protection in their skin from some really, really dangerous light. And Coao, Stephania, and Ruth have got to be slathered with sunblock all the time. And it's really, really difficult to stay on that because sunblock doesn't last for a long time. So at the end of the video, Rosemary was talking about she would like to know what the chances are that Joao Paulo, Rebecca, and Marie Alice might actually have this trait. So when they decide if they're going to have children, do they want to take that chance of possibly having babies that are also albino? Because the mom would say she would never wish that on any individual because it's been really, really hard for her children. So the way that we do this is something called a Punnett square. And I think that you are familiar with Punnett squares. So Punnett squares are used to predict the probability of an outcome. So we're going to take Rosemary and we're going to take biological dad for these children and we're going to put them together. So both parents are normal, but they're carriers. So we write this as a cross. We say, Mom is crossed with dad, biological dad, and they're both heterozygotes. So we write this as a cross. Okay, so we are going to cross these two individuals. And when we do that, we build a Punnett square. So we're going to take mom and dad. It doesn't matter if you put mom on the top of this square or dad on the top of the square, but we're going to build this grid. I'm going to divide it like so. And we're going to take one of the parents and we're going to put them on the side. So I'm going to put mom over here. And we have to take her alleles. She has got 2 alleles for albinism because we have 2 alleles for every trait that we have. Rosemary, mama, Rosemary had 2 biological parents herself. One of her parents gave her a big M, and the other parent gave her a little m. So these are Rosemary's pair of alleles for skin color. So when she goes to make her sex cells, her egg cells, her ova, she's not going to put both traits. Remember, sex cells have to have half of what the parents offer. So we're going to take mom's genotype and we're going to split them. Half of mom's egg cells will have a big M, and half of mom's egg cells will have a little m. So these are her, half of her egg cells will be big M, and half of her egg cells, or half of her other egg cells, will be little recessive M. We're going to do the same thing with dad. Dad is going to produce sperm, And again, his sperm can't have both traits. We have to take this set of traits that dad has and divide them in half. Remember when our sperm and our egg cells were made, that process is called the sex cell with meiosis, and we're cutting the number of chromosomes in half. So we're going to take dad's alleles, and we're going to put dad's big M in half of his sperm cells, and then we'll put dad's little m in the other half of his sperm cells. So dad makes 2 different types of sperm cells, and mom makes 2 different types of egg cells. So now we don't know which sperm and which egg are going to come together on fertilization day. So let's look at all of the options. If this sperm got together with this egg cells are huge, then we would have an offspring that had a big M, big M. Big M, big M, let's draw our attention up here, would be a normal child. If this sperm got together with this egg, big M, little m, this would also be a normal child, but it would be a child that was a carrier for the albino trait. Let's go with this sperm and this egg. If this egg had a little m and this sperm came together, then we would have big M, little m. Again, we would have another normal but carrier offspring. And then what if this sperm from dad joined with this egg from mom? And that would mean we would have an individual or an offspring, a child, a baby, that has 2 little m's. And 2 little m's means we have an albino. So these are all the options. And just because this pair of parents had a girl that had albinism first doesn't mean that they're not going to have them the rest of the way. This set of data are predictions every time this dad and this mom try and make a baby. These are the options. So let's make sure we see what this means. This individual, let's go with highlighters. This individual is normal. This individual is normal. And this individual is normal. So of the 4 offspring that we could make, 3 of the 4 are normal. And then we have 1 offspring that is albino. Okay, so that's the one that stands out. So the way that we would write this is we would say there is a 3 to 1 probability that the children will be normal to albino. So we could say 3 normal to 1 albino. There's another way of looking at this too, and this might be a better way if you don't like ratios. We could look and say we have, of the 4 offspring, 3 out of 4 offspring are normal, and 1 out of 4 offspring is albino. We won't use the ratio when we write them out as fractions because fractions are ratios. So if someone said, what's the chance that Rosemary and Joelle will have a child that has albinism? We would say that's a 1 in 4 chance, or a 25% chance. 1/4 is 25%. 3/4, what percent is that? That's a 75% chance. So this couple had a 75% chance that they would have normal child when they reproduce. But they made 5 children together, and 3 of the 5 have albinism. So what actually happens sometimes can be a little bit different from what's predicted. Okay?